Hello everyone. Today let's solve the problem number 417, Pacific Atlantic water flow, right? So what the question states here, we are given an m into n grid here. So we are given an m into n grid. You can clearly see here. We are given an m into n grid where each cell represents the height of the region. So each cell here represents the height of the region. So this is fine. This each cell represents the height of the region. So the Pacific Ocean touches the top and left edges. So you can clearly see it touches left and top edges. Pacific Ocean. So and the Atlantic Ocean touches the bottom and right edges. So Atlantic Ocean, you can clearly see here, it touches the bottom as well as right edges. So that's what they have given here. So water can flow from higher or equal height. So water can flow higher or equal heights. So what does it mean here? Water can flow from higher or equal height means, suppose if we are considering this height of 4 for this cell. So the value they have given here is 4. This is the height, right? So if the water has to flow to Pacific, so this previous one has to be lesser, right? To flow to the Pacific Ocean, either it can move here up or it can go left, right? So this the next cell, the value or the height of the next cell, it has to be either lesser or it has to be equal, right? So here 4, it is lesser, 2 is lesser than 4, this can go. Next we'll consider this one too, and here also 2 is lesser than 4, so this can flow into Pacific. So let's stop here. Next, let's check for the Atlantic. So here, to flow to the Atlantic, either it can move right or it can move down, right here. So we'll consider 7 here. 7 is greater than 4, so this fails here. This completely fails here. So for right also, here you can clearly see 5 is greater than 4. So 4 cannot flow into Pacific as well as this one, Atlantic Ocean, right? So this is one of the examples. So that's what they have given in the question, right? So water can flow from higher or equal height to a lower height in 4 directions. So that they have clearly mentioned here, either up, left, down, up, down, left or right? So water can flow from a higher or equal height to a lower height in 4 directions, up, down, left or height. So what we need to consider here then, so we need to find all the grid cells from which water can reach both the Pacific and Atlantic Oceans. So we need to find all the cells which can flow which can flow to both Pacific Ocean as well as the Atlantic Ocean. So that's what we need to find here in this case. So I hope this is clear. In this case, we need to consider one more thing here is this one here, accordingly with the diagram here, this one, the top right and the bottom left here, this one. So here 5 and this 5, this can flow both into Pacific Ocean and Atlantic Ocean. They have clearly mentioned. So here you can clearly see this, accordingly with the diagram, this cell, we can consider this one directly. So this cell, this comes under 0, 4, I think 4, 0 and 0, 4, as it is 5 into 5, this one grid. So this one 0, 4 and 4, 0, we can consider this one directly here. So this touches here, right? Pacific and Atlantic Ocean both. So here this flows directly into Atlantic and Pacific Ocean. Just keep this one in mind. So this is one thing. So what they have given in the output, let's see once here. So output is 0, 4, 1, 3. 0, 4 is nothing but this one, I think. So just give me a second here. Yeah, here 0, 4 is nothing but this one. I have already said this one. We can consider this one directly. And 1, 3 here, this one. Not 1, 3, 4, 0 and 0, this one, 0, 4. We consider this one directly. All other cells 1, 3, this one, 1, 3, 1, 4, and 2, 2 here, this 5. And 3, 0 and 3, 1 they have given here, these two. These are the cells that will flow this one to both Pacific as well as the Atlantic Ocean. So let's see the same thing in the approach. Let's discuss the approach entirely first. by considering this example itself. Then let's discuss all the edge cases followed by code. So finally, let's write the code and discuss the complexities of the code that we have written. Initially, as usual, let's discuss the approach, how and how we got this output basically from the grid, right? So let's see the. So here, let's discuss the approach step by step. First thing we have to keep in mind here is we are going with the BFS approach, breadth first search, right? So one more thing, I have considered the first example that they have given in the question itself, right? So let's start with this one. As I have already said that this this one and this flows directly into the Atlantic as well as the Pacific Ocean. So cells 0, 4 and 4, 0 we can directly consider. So we are considering here 0, 4 and 4, 0, which can so directly flow into Atlantic as well as the Pacific Ocean. Let's start from here, the BFS. So first one, it can flow to the Pacific Ocean. We can directly see here. We don't have any value at all at the left. It can flow directly to the Pacific Ocean. What about Atlantic Ocean? To go into Atlantic Ocean, to flow into Atlantic Ocean, it can either move right or it can either move down. Here you can clearly see here we have value 3, 2, which is greater than 1. This fails, and here here also you can clearly see 3 is greater than this one. What do we call 3 is greater than 1, so this fails here. Let's move to the next one, 2 here. Let's consider 2. This can flow into the Pacific Ocean, you can clearly see here, but here at it cannot flow into the Atlantic Ocean because we have 3 which is greater than this one. It will go here, it will go here. 3 is greater than 2, so this fails as well here in this case. In this case, vertically we have 4 which is greater than 2, so this fails here. So next, let's consider 2 here. 2, we have 3, so we can consider directly here as well up, so it can flow into the Pacific Ocean. But for the Atlantic Ocean, 3 here, either it can go right or down. Here we have 3 which is greater than 2, and 3 here also 3 which is greater than 2, so this also fails here, right? So next, let's consider this 3. So here it can go to Pacific Ocean, but 5, Atlantic Ocean, 5 is greater than 3, and this one 4 is also greater than 3 here, so 3 fails. 5 we can consider this one directly. We are considering this one 5 directly right here. So just give me a second. 5 we have considered directly. So next, let's come here. Let's come to 3 here. 3, it can flow directly into the Pacific Ocean, but here 4, in this cell itself row we have the higher value 4, so this fails for the Atlantic Ocean. Down also you can clearly see here 6, we this one for 6 we have, right? So this fails actually. So next, let's go into 2. 2, here 4 is there again. 4 is greater than 2, this fails right here. Next, if we come down here also we have 4 which is greater than 2, this fails. Let's go into 3. Let's check for 3. 4 we have in the same row, so for this one, it can flow into this one, Pacific Ocean. You can clearly see here 2 less than 3, and again 3 less than this one, right? Equivalent to 3, so this can flow into Pacific Ocean, but here it cannot flow into Atlantic Ocean because we have 4 and we have 5 basically, which is this one greater than 3. This one also fails here. Let's consider here 4. So 4 here you can clearly see the value 4, 4 is equivalent to 4, so this can flow to Atlantic Ocean. And 4 here, this one up, if we consider 3 is less than 4, and it can flow to Pacific Ocean as well. So this satisfies the condition basically here. This one we have to consider nothing but 1, 3 in this case. So this 4 also it can directly, this one flows into Atlantic Ocean, no value at all. So here we can clearly see here 4 left side, 4 is equivalent to 4, so we'll move to next cell. So this is less than 4 is 3 is less than 4. Next we will move to next cell. 2 is less than 4. Next 3 is less than 4. So it flows to specific quotient as well. So we will be considering this cell as well. 1 comma 3 and 1 comma 4 satisfies the condition here. In the second row we have to consider this one, 1 comma 3 and 1 comma 4. So I'll just come here. Let me write here 1 comma 3 and 1 comma 4. I hope this is clear. Again I'll come to the third cell. So third row here 2, it can flow to this one here directly, Pacific Ocean. And what about Atlantic Ocean here? 6 we have in this one when we consider down. Either we can move right or down, right? 6 we have. So this cannot go down. For the right here you can clearly see 4 we have. So this fails. 4 is greater than 2, right? Same thing. Let's move on to the 4. 4 either down or right for the Atlantic Ocean. So it can flow to Pacific Ocean because 2 is lesser than 4, so it can flow to Pacific Ocean. Here 5 is greater than 4 and 7 is greater than for this one 4. So this fails here. Let's consider, just give me a second here. Let's consider this one 5, next one. So 5 here you can clearly see it can flow to Atlantic Ocean here because 3 is less than 5, 1 is less than 5 as well. So it flows to Atlantic Ocean. But for the Pacific Ocean as well. So 4 here, left side 4 is less than 5 and 2 is less than this one 5 as well. So it flows to both Pacific and Atlantic Ocean. This one we have to consider. This satisfies the condition here. So satisfies the condition that they have given here. So this one. In this row we have to consider 5. So next let's move into 3. 3, this can flow into 2 comma 4 and this can flow into Atlantic Ocean here. So 1 is less than 3, so it can flow into Atlantic Ocean. But up if we consider 4, we have this one greater, so up we cannot go. And left side we have 5. 5 is greater than 3, so left also we cannot go. So up and left if we cannot go, so this fails the condition. For the Pacific Ocean it can only go to the Atlantic Ocean. Let's consider 1 can directly get into Atlantic Ocean. But for the this one Pacific Ocean, so you can clearly see 4 is greater than this one 1 and 3 is greater than 1 as well. This fails. From the third row we have only one, this one 5, right? 5, this one can flow into both this one Atlantic Ocean as well as the Pacific Ocean. I hope this is clear. So let's come to the fourth one. We will consider this one 6 now. So 6 here you can clearly see it can directly get into Pacific Ocean. And for the Atlantic Ocean, see here 5. Next cell 5 is lesser than 6, so it can get into Atlantic Ocean as well. So here this satisfies the condition, so we will be considering 6 here. So this will be 3 comma 0, right? So I'll just come here. Let me give 3 comma 0. Same goes with the 7. Let's consider 7 here. 7, 6 is less than 7 here and it will flow. This will flow to the this will flow to the Pacific Ocean. And 7 here you can clearly see 1 is less than 7 and this will flow to the Atlantic Ocean as well. So this satisfies the condition. So here we have to consider 7 as well. So now we have got this 0 comma 4, 1 comma 3, 1 comma 4, 2 comma 2, 3 comma 0 and this one 3 comma 1. So 1 so here value is 5, up it cannot go, value is 7, left it cannot go, right also it cannot go, and yeah, down also it cannot, down it can go, Atlantic Ocean it can go, but it cannot get into Pacific Ocean. So next same goes with 4 as well. For 4 it can it cannot go this one left because 7 is greater than here this one 4, and here it can reach the Pacific Ocean. Here you can clearly see 3 4 3 is less and 4 is equivalent to 4, then 3 less than this one 4. It can reach the Pacific Ocean, but Atlantic Ocean, it cannot write here because 5 is greater than 4. And just give me a second here. So sorry, this one 4, this will go to 3 here. 3 and 4 will consider here. 4 is greater than 3 here. This fails. So this also fails here. 5, it can flow into Atlantic Ocean. But for the Pacific Ocean, it has to either move left or up right here. So 1, so this is fine. 1 is less than 5. So next 4, this one 4 is nothing greater than 1 here. So this one fails. Left 4 is less than 5. This is fine. Next 1 is less than 4. This is fine. But 7 is less than 7 is greater than 1 here. In this case, this also fails here. From this row, we are considering 3, 0 and 3, 1. This one also fails actually. So here 3, 0 and 3, 1 we are considering right here. So here 3, 0 and 3, 1. This is fine. We'll go with the final row. So let's come here. 5. This can directly flow into this one, Pacific Ocean. We have already considered this one, the first one, 4, 0, sorry. This one, right? So this one we have already considered, right? So this one is fine. So next let's consider 1. So here for the Pacific Ocean to enter here, you can clearly see 5. This is greater than 1. This fails. And 7 is also greater than 1. This fails here. So this we can directly give here. So for the same 1 here, you can again consider here 1 is less than 1. This is fine. 1 is equivalent to 1. This is fine. And 5 is greater than 1. This fails. And for the Pacific Ocean also, here 1 is less equivalent to 1. This is fine. But greater than 5 here. This one 2, 2. So this fails as well. So 4, 3. This one let's consider for 2. 2 to enter into Atlantic Ocean. So this is 4 greater. So this fails. And 2 it can enter directly here to Atlantic Ocean. For the Pacific Ocean, here you can clearly see 1 is less than 2. This is fine. 2 is 1 is equivalent to 1. And finally 1 but is 5 is greater than 1 here. So this one fails. To move up, 4 is greater than 2. This one also fails. So the final one is 4. This one 4, 4. 4 we have to consider, right? So this will directly get into Atlantic Ocean. For the Pacific Ocean, either it has to move left or up, right? For when we consider the above cell, 5 is greater than 4. This fails. Left side we have 2. Okay, this moves here. 2, then it moves to 1 because 1 is less than 2. Next we will move to 1 because 1 is equal to 1. Finally, this one is less than, 5 is greater than this one, 1. So here it fails. So here also this fails. From this row, we are considering only this one, 5. The first one, we have already considered that one, right? 4, 0. So these are the cells. So from which the water can reach either this one. Water can reach both this one, Pacific Ocean, as well as the Atlantic Ocean. I hope that's what they have given in the answer as well. Let's check this one, 0, 4, 4, 0, 1, 3, 1, 4, 3. So this might not be in the order, but all the cells that can visit both Pacific and Atlantic Ocean are these cells. You can just check the output that they have given in the solution. Example 1. So just give me. So you can clearly see here 0, 4, 1, 3, 1, 4, 2, 2, 3, 0, 3, 1 and 4, 0. So this is what we got here as well. 0, 4, 4, 0, 1, 3, 1, 4, 3, 0 and 3, 1. So I hope this is completely clear, the approach. So this works absolutely correct, right? We just went with the DFS. So next, let's discuss the edge cases one by. So the first edge case that we'll be considering here is smallest case. Here in this case, I'll just consider input 1. We have only one value or one height that is given here in this case. So the output will be directly we can consider here 0, 0, the cell. it moves to both Pacific as well as the Atlantic Ocean, right here. Only one cell because it can reach both the oceans here, 0, 0. This is for the first edge case. For the condition smallest case. Second one, increasing heights here. Increasing heights. So here, input, let me consider here 1, 2, 3. Yeah, 4, 5, 6, and 7, 8, 9. This is fine. So the output will be here, all the border cells. Border cells means first, in the example that we have considered, same thing, right? Bottom right and top right and bottom left will always flow into Pacific and Atlantic Ocean. So this one, border cells plus some central cells. So you can just visualize in the same way, or you can just try in the same way that that I showed for the example 1. So the output will consist of all border cells and some plus some central cells. This is fine. This is for the second case, increasing heights. Let's move on with the third edge case, nothing but decreasing heights. So I'll just give here decreasing heights. So let me consider here decreasing heights. Decreasing heights input has to be in the decreasing way, right? So I'll just give here 9, 8, 7. Yeah, 6, 7, 5 or 6. Oh, decreasing I'm considering, right? Sorry, just give me a second here. 6, 5, 4. Finally, 3, 2, 1. This is fine. So the output will be only border cells here because it is decreasing value. So suppose if we consider up, left, down or right, I mean suppose if we consider horizontal or the this one vertically, so the previous value will always be greater, right? So only the border cells will flow into the this one, Pacific Ocean as well as the Atlantic Ocean. That's what we saw. So we saw this one, right? So you can just visualize in the same way for the example that one I have showed. So this one output will be only border cells. Because whenever we compare, right, whenever we perform DFS, so the previous cell will always be greater, right? So it cannot flow into this one except the border cells. No cell can, no height or the value in the cell can flow into both Pacific as well as the Atlantic Ocean. So let's discuss the final edge case here. This one, same height everywhere. So I'll just come here. I'll just give here same height everywhere. So here, the input, let me consider here same height. Let me give, you can consider any value. I'll just consider 5 here, 5, 5, 5. So let me consider one more 3 into 3. So here, yeah, this is fine. So the output will be here entire grid. So entire grid, each cell can flow into this one, Pacific as well as the Atlantic Ocean, because so the rule is either the previous value that we considered, so we can move up, left, right or down. Either the previous value that we are considering, it has to be either equal or less than the previous value, right? And we can move horizontally or vertically. In this case, it satisfies the condition each cell is equivalent, right? The value is equivalent. So entire grid we can consider here. Water can flow everywhere. So the output will be entire grid, right? So I hope this is clear. All the edge cases are clear. The first one that we considered for smallest case, second one we considered for increasing heights, third one we considered for decreasing heights, and the final one we considered for same height everywhere. I hope this is completely clear. All the edge cases are clear. Now let's start writing. So here, let's start writing the code. Initially, we have to get the grid dimension. So I'll just give here, let m equals length of the heights. We have two parameters, one parameter heights, right? So we are just getting the grid dimensions, and n I'll just consider here, sorry, column. For the column, I'll just consider heights of 0 dot length. So this is for the rows and this is for the columns. We are just getting the grid dimensions here. So the next line, what we'll do, we need bit arrays for the ocean, right? We need bit arrays for the oceans. For the Pacific Ocean, I'll just consider PAC here. I'll just consider type arrays. So I'll just go with unsigned 8 array, right? Unsigned integer arrays. So uint 8 array. So I'll just give here 8 array. So this one will be m into n for the Pacific Ocean. So for the Atlantic Ocean also, it will be same. New unsigned integer array, I'll just consider 8-bit of 8-bit. Unsigned integer array I'm considering of 8-bit. So I'll just go with here array. So this will be m into n as well. So we need to store the result somewhere. So I'll just consider the result variable here. I'll just initialize this one to the empty array initially. So directions we can move here while we are making use of grid. I mean this one BFS. One thing we have to keep in mind here, the direction we can move here as up, right, down and left. So directions I'll consider directly here. Just consider DIRS for the directions. So this one will be -1 0 1 0 and -1. I hope this is clear. So next we'll be making use of the helper function because we have to perform BFS, right, to mark the reachable cells or to we have to find the cell value which can flow into both this one Pacific Ocean as well as the Atlantic Ocean. So that is the reason we'll be making use of the BFS function here, helper function. I'll just give here BFS. You have two parameters, one is Q and one is ocean. So as we are going with the this one BFS, we'll be making use of the Q, right? So we should be having some value within the Q. So while we have value, I'll just give here while Q dot length. So what we'll do initially, we will extract row, column and compute one dimension index here. So how can I articulate that one in the form of code? I'll just give here row, column. This is fine. Q dot shift. So because we have to extract row as well as column and compare the 1D index, right? So I can just give here Q dot shift and I equals R into n plus C. I hope this is clear. We are just extracting row, column and computing the 1D index. So this is fine. Next, we have to mark the cell as reachable for this ocean. Every cell we have to do the same thing, right? So how can I do that? I'll just give here ocean of I. This one we have to mark. Let's mark this one with 1. So I hope this is clear. So we have to iterate over all the 4 possible directions. So we are going with the BFS, not the DFS. We are going with the breadth first search, right? So this is here we'll be going with the iteration. So if we have went with the DFS, we should have considered recursion. In this case, we'll be going with the iteration as we have chose this one BFS for this particular problem. So it can be solved by DFS as well. So we are going with BFS here. So we are iterating over 4 possible directions. One is up, down, nothing but vertically. Left and right, nothing but horizontally. Here I can just write in this way for d equals 0, d less than 4, because we have 4 directions. Increment the direction. This is fine. So next thing is we have to compute the next cell index. So for each cell we have to compute, right? So next thing we have to compute next cell index. This will be here. I'll just give here nr. I can consider any variable name. I'll just consider here nr. So this one will be plus directions of d. This one, let me consider here nc, c plus directions of here d plus 1. This is fair. Finally, Ni, this one, Nr into N plus Nc. So what is this basically? We are just computing the next cell index here. Is this fine? So I hope this is fine, right? We are just computing the next cell index here. So next step here is we have to check boundary conditions. We are checking boundary conditions and we have to ensure height is non-decreasing. So we have to check for every boundary, right? So we saw that one where we considered the first example that they had given in the question. So approach that we had discussed earlier, right? So we have to check boundary conditions and we have to ensure height is non-decreasing always. So we saw this one in the edge case. When height is this one decreasing, then the previous value will always be this one greater than the current value. So every time it doesn't satisfy the condition at all, right? So we are going with the two conditions here. We are checking boundary conditions as well as the we have to ensure height is non-decreasing. So simple if condition Nr greater than or equal to 0 and Nr less than M and Nc greater than or equal to 0 here and Nc less than N here and of ocean of Ni. So height, this one we have to consider height now. So also heights height should be not decreasing, right? So this one height of Nr and Nc, this one should be greater than or equal to heights of row and column. So I hope this is clear, whatever I have written here. So I hope this is clear. So then I can write one thing. I'll just write this one directly here. In that case, what we will do, we will push the valid cell into the queue that can flow into both Atlantic and Pacific Ocean. For adding, I'll just make use of push here. And we are pushing valid cell into the queue. So we have to just mention here within the array NR as well as the NC, row and column. So this is fine. I hope this is clear. So the next step here is, the final step here is, we are making use of the queues for BFS from Pacific and Atlantic Ocean, right? So this is not the last step. So here we are considering queues for the BFS, right? From Pacific and Atlantic Ocean. I can give in this way. So Q1, let Q, so I'll just come here. I have to come out of this one entirely, right? So let me come out of this one. So we just performed BFS here. Let me come out of the BFS function entirely here. So I forgot this one. So this is fine. This is just we are performing the DFS here, right? So after this one, what we'll do, I'm just initializing the queues for BFS from Pacific and Atlantic Ocean. Two queues, Q1, let me initialize this one to the empty array. Also Q2, let me initialize this one to the empty array. Next step is we have to add all the Pacific border cells and we have to add all the Pacific border cells and just give me a second here. Also we have to add this one Atlantic border cells as well, right? So how can I write this one? We have to go with the iteration here. So I'll just give here I equals 0, I less than M. Let's increment I here. Also Q1 dot push. Here we are adding all the Pacific and Atlantic border cells here. Q1 dot push I comma 0. This is fine. And Q2 dot push here. This one will be I comma N minus 1. This is fair. So here we are considering first and last columns. here for this one Atlantic border cells, we will consider first and last rows. So here let me give for let I equals 0, I less than n. Let's increment the I here. So this one will be q1 dot push 0 comma I. So this is fine. Here same thing, q2 dot push. So first and last rows we are considering right here. So this one will be m. M is nothing but rows. M we have considered, right? M minus 1 comma I. So I hope this is clear. I should have copied the same thing and made necessary changes. This is fine. Next, let's perform the BFS from Pacific border, and also let's perform the BFS from Atlantic border. So this will be BFS of Q1 comma PAC Pacific, and I'll copy the same thing. This one we have to perform BFS from Atlantic border, right? This one will be Q2, and this one we have considered for the Atlantic, we have considered ATL, I think, right? So where is this one? Yeah, ATL we have considered. This is fine. BFS of Q1 Pacific and Atlantic, this is fine. So finally what we have to do, we have to find all the cells that is reachable from both oceans. So again, for loop for let I equals 0, I less than m into n I plus plus. So this is fine. So I'll write a simple if condition here. If Pacific, iterated value of the Pacific, PAC I have considered, and let me include Atlantic as well, because the water has to flow into Pacific as well as the Atlantic Ocean both, right? Iterated value of the Pacific as well as iterated value of the Atlantic here. Then we have considered the variable result, right? So I'll just push this one to the result res dot push off here. We can just consider mat dot floor, or I'll just go with the double tilde operator here. This is fine. I by n here, comma I module n. So this is fine. So we are just finding here the cells that is reachable from both oceans, right? So the final thing is we need the result, right? We are saving this one in the result. Here clearly we can see here. So also I have considered result variable here. You can clearly see here, right? So let me return the result here. So let me format this one once and let me hit the rub button. I hope this works. Let's see. Oh, runtime error here. Function is not iterable. Cannot be property of line number 8. So just give me a second here. Q, right? So this was saying function is not. Oh, here we can clearly see shift. This is function, right? So yeah. Let me run this one again. So I forgot parenthesis. So now you can clearly see the sample test cases are getting passed here. So the code works absolutely correct in this case. So let me hit the submit button now. So you can clearly see here all the test cases are getting passed here. So the code works absolutely correct in this case. So let's quickly discuss the complexities of the code that we have written. So the approach that we went with here is BFS, right? What would be the time complexity here then? So the time complexity would be here big of m into n. So why it is big of m into n? Because each cell is processed at most once in the BFS traversal. We are making use of the BFS traversal here. BFS and Q we are making use of, right? So each cell is processed at most once in the BFS traversal, and we run BFS twice, because once we are running for the Pacific and once we are running for the Atlantic. So overall time complexity would be here big of m into n. So what would be the space complexity then? The space complexity would be big of m into n as well. Why? Because we are making use of two unsigned integers, right? 8-bit arrays. So here you can clearly see we are making use of two unsigned 8-bit integer arrays, right? So here one is for Pacific and one is for Atlantic, nothing but PSA and ATL we have considered, right? One is for Pacific and one is for Atlantic. So the Q in the BFS has at most big of m into n elements in the worst case. So we are making use of two unsigned integer 8-bit arrays. One is for the PAC, nothing but Pacific, and one is for the Atlantic ATL that we have considered of size m into n. And the Q in the BFS has at most big of m into n elements in the worst case. That we know, right? So here overall time complexity and the space complexity of the code that we have written is big of m into n. I hope the solution that we have written is completely clear. For now, this is it. Thanks for watching, guys.